Hi, topic for this session is binary number system, fractional conversion and arithmetic. The fractional decimal number or the fractional part of the decimal number can be converted to binary by multiplication of 2 until the fractional product is 0 or the desired number of decimal places is reached. This is the basic protocol of converting a fractional decimal number to a fractional binary number, right? So there could be two cases. One, multiplying the decimal fractional part of the decimal by 2, we eventually get 0, or we might not get 0, we keep on like getting a lot of bits, but we desire to get a maximum of say 4 bits or 4 digits after decimal, so we can stop after that, right? So there are, I again repeat the protocol. It says fractional decimal number can be converted to binary fractional number or binary number by multiplication of 2 until the fractional product is 0 or desired number of decimal places each is reached. So in these cases, carry digits or carries that we get generated by the multiplication produces the binary number. If you do remember, why we convert the normal decimal number into binary, we uses what? Remainders. But in this, while we are converting fractional decimal number, we uses carries, right? First carry produced is the MSB, most significant bit of the fractional binary number, and the last carry is the LSB, least significant bit, that is the rightmost bit of the binary number. The conversion of the numbers before and after dot is done separately. Suppose we take an example of converting a decimal number 4.15625 into binary. So as we have already discussed in the previous slide, that we convert the number before the dot and after a dot separately. So let's start with converting the number after the decimal. So the decimal number is, or the fractional decimal number is 0.15625. So we multiply it by 2 to get 3125, and the carry is 0. Then we again multiply the number 0.3125 that we got in the previous step by 2 to get 0.625, carry is 0. Third time when we multiply the result of the second step to 2, we get 1.25, 1. Then we again multiply 0.25, the fractional part, into multiply by 2, that gives us 0.50, carries 0. Then again we multiply 0.5 into 2 to get 1, that is just the carry, and the answer comes to, or the fractional part comes to 0. Now if you do remember, when we convert the remainders in a normal decimal number, we go from bottom to up, but this is after the decimal, so we go from, for the carries, from top to bottom. The first carry becomes the MSB and the last carry becomes the least significant bit. Binary value of fractional part, that is 0.15625, is 00101, and for the number towards the left of the dot is 4, the binary of 4 is 100. Hence the binary equivalent of 4.15625 is 100.00101. Now we'll convert the binary number in fraction decimal. So let's take an example of 100.10101. As we have already discussed, the portion on the left and the right of the decimal or the dot is done separately. So for the part of the left hand side, 100 is equivalent to 4. Right hand side part of the dot, what we do is we have 0.10101. So we'll convert it back to decimal using similar method. that we used to do in case of normal numbers. Only different, there are a couple of differences to that method, is we start from the leftmost bit MSB, raise the powers in negative of 2. So 1 into 2 to the power minus 1 plus 0 into 2 to the power minus 2 plus 1 into 2 to the power minus 3 plus 0 into 2 to the power minus 4 plus 1 into 2 to the power minus 5. So there are two differences. One, we start increasing the powers of 2 from left to right. Second, the powers are in negative. Okay, so it equates it to 1 into 1 by 2 plus 0 into 1 by 4 plus 1 into 1 by 8 plus 0 into 1 by 16 plus 1 into 1 by 32. For neglecting the 0 digits, we get 1 by 2 plus 1 by 8 plus 1 by 32. That becomes equal to 65625. Right. Therefore, finally, the decimal equivalent of 100.10101 is 4.65625. Now coming back to the arithmetic of binary number system. So first we talk about addition. The binary addition goes like this: 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, and 1 plus 1 is 0 with carry 1. Let's understand this with the help of an example. Binary addition of 2 and 11. Suppose we have a number written in binary 2 and 11. They are two numbers. So binary equivalent of 2 is 0 0 0 1 0, and the binary equivalent of 11 is 0 1 0 1 1. Now we start adding from the right hand side. 0 plus 1 is 1, 1 plus 1 is 0 with carry 1. So 1 carry goes up. So when we have 0 plus 0 is 0 plus 1 carry, so answer is 1. 0 plus 1 is 1, 0 plus 0 is 0. The result is 0 1 1 0 1, that is 13. If we add it in decimal, 2 plus 11 is 13. This is how binary addition goes. Okay, let's take another example to understand it in a much better way. So suppose we have a number 1 0 1 0 1 1 1, and another number is 1 0 0 1 0 1 1. So again we start adding bits from the right hand side. 1 plus 1 is 0 with carry 1. So we have 3 ones in the second step. When we add 3 ones, we get 1 with carry 1. So we have 2 ones. One is the number, another is carry 1. So we get 0 with carry 1. Again we have 2 ones. One is the number, another is 1 is carry. So 1 plus 1 is 0 with carry 1. Then we have 2 ones again. We get 0 with carry 1. We have two numbers, both are 0 plus carry 1. That becomes 1. Then both the bits are 1. So we get 0 with carry 1. Hence, the addition of these two numbers is equal to 1 0 1 0 0 0 1 0. Alright. I hope we are clear with this. Okay, let's start with subtraction now. So subtraction uses the concept of borrow as we do in normal subtraction of decimal numbers. So starting from the right, 1 minus 1 is 0, 1 minus 1 is 0, 1 minus 0 is 1, again 0 minus 1. So 0 is less than 1. Therefore we take a carry from the immediate next bit on the left. So if we carry 1, it comes as 2. Right. By 2 we mean there are 2 ones. Right. Because binary number doesn't have a number called 2. It only has two numbers, zeros and ones. So it has 2 ones. Right. So we have 2 ones, that subtracts 1. 1 1, we get 1. Right. Then this one becomes, next one becomes 0 for here. Then 0 minus 1 is not possible. Again we take a carry from here. So it doesn't have any value, so you cannot give it the carry. We take it from here, it becomes 2. It gives one of it one to this particular row, right? Therefore it becomes 1. So this becomes 2, it becomes 1 after taking value from here. So this 2 minus, now this 2 ones minus 1, because this is already become 0, so we get 1. Okay, so we get 1. Here we only have 1, so 1 minus 1 is 0, and here we have already shifted it as a carry to the right hand side, so it's left with 0, so we have 0. Say subtracting 1 triple 1 0 double 1 from 1 0 1 0 triple 1, we get 0 0 triple 1 0 0, right? And third important arithmetic in binary is complement. So how to find ones and twos complement? Suppose we have a number called 1 0 1 0 triple 1. We need to find ones complement. In ones complement, simply we have to reverse the bits. If it's 1, we make it 0, or 0, we make it 1. So ones complement of 1 0 1 0 1 1 1 is 0 1 0 1 triple 0, right? Now for finding the twos complement, we add 1 to ones complement of the number. Therefore we get 0 1 0 1 0 0 1. That is twos complement of 1 0 1 0 1 1 1, right? Internally, twos complement method is used to subtract two numbers. For detailed process how it goes, you can refer to a supplementary video or this particular URL.